Hi, my name's Stewart Lynch. In this video, I want to add to my Deeper Understanding series by taking a look at Swift operators and custom operators. Operators are fundamental to programming, and Swift provides a powerful way to define your own, so let's get started. I love getting your feedback, so tap the thumbs up button if you enjoyed this video and leave a comment below. Make sure you subscribe to the video and ring that bell to get notifications of new videos. And if you want to support my work, you can buy me a coffee. I have a starter playground for this project, and I recommend that you download it from the link in the description. Download the starter branch, and then you can download the zipped version. There is a completed branch as well that'll contain the completed code, but I recommend that you work along with me, as you'll gain a better understanding if you do that. The starter project contains 4 different playgrounds, and you can access them from the table of contents or from the navigation pane on the left. Now in Swift, we use operators all the time. An operator is a special symbol or phrase that you use to check, change, or combine values. And operators are a fundamental part of programming languages, enabling you to perform various operations on data types like numbers, strings, and more complex structures like arrays and other objects. And you use these all the time in Swift. Now there are 3 different types of operators. They are Infix, Prefix, and Postfix. So before we jump into creating custom ones, let's quickly look at some examples of each. Infix operators are placed between 2 operands. And they're the most common type of operator. They're used to perform operations on these operands, which can be variables, constants, or expressions. And they're called infix because operator is placed in the middle of the operands. Let's take a look at some examples. I can't cover them all here, but here are some of the categories. For example, arithmetic operators. We can let the sum be a variable which is equal to the sum of the 2 operators 5 plus 3, where the plus is the operator. And if I print the sum, I get the answer. Sometimes there are compound assignment operators. So for example, if I have a variable a that's 5, and then I can use plus equal, those 2 operators together, and go a plus equals 3, and when I print a, I get 8. There's comparison operators. For example, we can let is greater than be equal to 5 greater than 3, and that's going to return a Boolean value. So when we print that out, is greater is true. And there are logical operators, infix operators. So we can let an AND result be equal to true, and is the AND operator false. So in this case, true and false is going to be false. And if we switch that AND to an OR and print again, we get the opposite result of true. And there are more like bitwise, range, and nil coalescing operators. I encourage you to do the explorations there on your own. So let's take a look at some prefix operators. They're fewer, but widely used. And they're the operators that are placed before the operand. And 2 of the most common ones are the unary minus operator. For example, if I let x equal to 5, and then print minus x, where minus is the operator, we'll get negative 5. And the other is the logical not operator, which is an exclamation mark, but it's often called a bang. So if I let is true be equal to true, and I can say then let is false be equal to not is true, or bang is true. And if I print is false, you can see the result. And then there are postfix examples, and they're the operators that come after the operand. Let me cover the 2 most common ones we used in Swift. The first is optional chaining. For example, let's say you have an optional string variable. And at some point, you could assign a value to the string like this, where we'll let optional string be equal to hello. And then later on, you want to determine the count of the number of characters in that string. And then in this case, then we can say let length be equal to the optional string dot count. And then as soon as we add that dot count, Swift is smart enough to realize that optional string is optional, so it adds that question mark, which is the optional chaining operator in between. And then when we print length, we'll see that we get an optional result. Now, if you're absolutely convinced that you have assigned a value to the optional string, you can use another postfix operator, and that's the forced unwrapping operator, which is another exclamation mark or bang. But don't confuse it with the prefix operator of negation. So we can let non-optional be equal to the optional string with the exclamation mark, which is force unwrapping it. And then if I let length 2 equal to the non-optional dot count, this time there is no optional chaining operator placed in between because non-optional is in fact not optional. So when we print the length, we actually get that value. Now you should rarely ever force unwrap something. We could use an if let to unwrap it to another variable like this. I can say if let my string is equal to optional string and then print my string.count. If the optional string is nil, however, we can use an else statement to provide an alternate value, say 0. So now our result is a non-optional result. But the other is you could use an infix nil coalescer operator. So if we printed the optional string.count, we can use the nil coalescer to provide the alternative if it's still nil. Custom operators allow you to define your own operators in Swift. And this can be useful when you need to perform operations that aren't covered by standard operators. Let's take a look at an example. If I type in Swift print 3 and then $2, what do you think you'd get? Now, if you've taken any mathematics at any level, you would have learned that 3 $2 means 3 to the power of 2, or 3 squared. But if I try this here, we get 1. And in Swift, that caret operator, it's not used for exponentiation. Instead, it's a bitwise XOR, or exclusive OR operator. And the bitwise XOR operator compares each bit of two numbers and returns a new number whose bits are set to 1, where the corresponding bits of the operands are different, and 0 when they're the same. So in our example then, the binary representation of 3 is 1, 1. And if I XOR that with the binary representation of 2, which is 1, 0, I get 0, 1, which is decimal 1. Now, if we want to be able to do exponential functions, we'll need to use the power function, pow xy, where you can provide the base and the power as two arguments. So pow 3, 2, in that case, we'll get 9. Well, what I'd like to do is create my own version of a custom operator that will do that for us instead of remembering that pow function. And the pow function has a number of different initializers, but I like the one where the base and the power can be any double value. There are basically two steps that you need to perform when creating a custom operator, and it has to be created outside of our example code closure. You'll need to define the operator and specify what type it is. For example, to perform an exponential operation in Swift, this has two operands, so this is an infix operator. And we can choose a new symbol, or we can simply combine two, like two of these carets together. So we have an infix operator of these two characters. Next then, we'll need to define the function where caret is the function label, and then we can provide the two operands as arguments, specifying that those two types must be doubles, and it's going to return another double. So we'll say that the left is a double, and the right side of the argument is going to be a double, and both doubles will return a double. So then within the body of the function, then we'll return the pow function using these two arguments. Now we can use, instead of pow 3, 2, we can simply use 3, 2, and we get 9 as expected. But what if we mix our operators with multiplication like this, where we have a 4 times 5 raised to the power of 2? Well, now we'll get an error saying adjacent operators are in unordered precedence groups, multiplication precedence and default precedence. So the first one, the multiplication, has what's called a multiplication precedence order of operations, while the second is the unordered default precedence. So let's give our operator the same precedence as the multiplication precedence in our definition of the operator. Now when we run our playground, we get the answer 400. But from our schooling, we know that powers should be executed first. It's multiplying 4 times 5 first to give 20, and then raising that to the power of 2, and that's why we get 400. And that's not the correct answer. The order of operations say that exponents should be done first, so it should do 5 squared to give me 25, and then multiply by 4 to get 100. So in this case, then we'll need to define our own precedence group and indicate which order the operation should be taken. And in Swift, a precedence group is used to define those precedence and associativity of custom operators. And precedence determines the order in which operations are performed in an expression with multiple operators. And associativity determines how operators of the same precedence are grouped in the absence of parentheses. So there are two things we need to specify: order and associativity. So we'll create a new precedence group by simply using the precedence group struct, and we'll give it a name, and I'll call mine exponential precedence. And we'll need to specify the order, and we do that by saying higher than, and the precedence that it's going to be higher than is the multiplication precedence. And then we specify the associativity, which is to associate it to the right, which means that if there are multiple operators of the same precedence that are grouped from right to left. Now we can return to our operator's definition and change the precedence to exponential precedence. And this time we get the right answer. Let's try a little simpler example. If you have two strings that are first name and last name, as I have here, let's say I want to create an infix operator that will join them together to give a full name and therefore put a space in between. But we're going to have to account for the fact that a first or a last name might actually be an empty string. So I'm going to create an infix operator where the precedence is the same as addition. And I'm going to use a combination of plus and percent as my operator. Now I need the function that is named plus percent, and it'll have a left and right parameter. Both of them will be strings, and it's going to return another string. Now you can try simply by returning the left string plus a space plus a right string. And then I can use this operator in my code block to print first name plus percent last name, and it works. But if I take the first name and make it an empty string, this time we get a space before the last name, and that's not what I want. But in our function, we can solve this by trimming the result using trimming characters in white spaces and new lines character set. Now when I run, we get exactly what I want. Well, prefix operators are a little easier to create. There's no need to specify a precedence. A prefix operator is applied directly to the single operand to the right of it, and it'll be applied before anything else. So if we want to find the square root of a number in Swift, we need to use the square root function, the sqrt. So let's first define our prefix operator using that option V to get the square root symbol. Next, we'll define the function that will operate on the following operand using the square root symbol as the function name. And the parameter, a single one, will just be a double, and it will return a double. And then in the body, we'll use the square root of whatever that value is. This time, though, our function must also declare that the function is a prefix operator function. The reason being is that the postfix function has the same signature. Now back in our code block, we can use this. We can simply print square root of 2 using that option V symbol in front of the 2, and we get exactly the same result. Now on to custom postfix operators. In the example for the postfix function, I have a multi-line string already set up. If I run the playground, I see that there is a space at the beginning. There are 2 line feeds after line 1, and then there's a line feed at the end, but there's also a space in that line that you can't easily see. I'd like to create a postfix function that will replace multi-line line feeds with a single line feed if there are 2, and then trim all the leading and the trailing characters and the final line feed if there is one. So I'm going to start by defining a postfix operator, and I'm going to use less than minus sign as my postfix operator. Next, I'll create the postfix function using that less than equal as the function name, and it'll have a string value parameter, and it's going to return another string. In the body then, you can use the replacing occurrences and then look for 2 new lines in a row. And a new line is \n. So we can have 2 of those in a row and then replace that with a single new line in the replacing. However, what if there were 3 in a row? It'll remove 2 and then replace 1, still leaving you with 2. What we can use is a regular expression in our search. And in regular expression, you need to provide a pattern that will check for 1 or more characters of the same type, and that is to use the regular expression with a plus that will check for 1 or more consecutive strings of the same type. And a new line string is that \n. So you might think I could simply use the string \n followed by a plus, and that would be the pattern. However, / is a special character that needs to be escaped. It just so happens that the way that you escape is to use another \. So the pattern that we really want is \n plus, looking for 1 or more occurrence of the new line character. And then we'll replace all of those with a single new line. However, this is right now just a regular string. In order to specify that it is a regular expression, we'll need to provide the options argument and then specify that it is a regular expression case. And then for the range, I'll say nil. This will still have the trailing space and new line. So we'll need to use in our function the trimming characters in white space and new lines. As I test now, I see that we have all of the extra spaces at the front and the end removed. Now, since this is a prefix function, we can only apply it to a string. So I could move that function into a string extension. So all I have to do is create an extension to string, and then create this function that we have, but it needs to be a static function, and I'll replace value with self. Now, since I moved this into an extension, I'll have to make sure that I remove it from the root file level though. And it works the same. And for one final example, I'd like to create a postfix function for ++. And this is a deprecated function in Swift that we have used in the past, and JavaScript devs use it all the time. What this does is increment an integer variable by 1. For example, if I have a variable x is equal to 5, I could say print x++, and it would simply print 6. But that doesn't work in Swift right now. So I'll create a postfix operator for this. So postfix operator ++. And since this will be operated on an int, I'm going to create an extension for int. And I'll create a postfix static func with ++ being the function name, passing in self, which is an int, and it's going to return an int. And then in the body, I can use the infix operator +=1 to add 1 to self and return self. This, however, creates an error. Left side of the mutating operator isn't mutable because self is a let constant. Well, we can solve this by applying the keyword in-out to our integer. When you pass a variable into a function, normally that function receives a copy of the variable, and any modification to this copy don't affect the original variable. With the in-out keyword being used, though, you pass in a variable as an in-out parameter to a function. It means that the function can modify the value of the variable, and those changes will persist after the function call. And now in our code block, we can use our new postfix operator on our variable. And when we print it out now, we see that it's been incremented by 1. Now, as I'm looking at my results here, it's bugging me that there appears to be an extra line in our first function. And indeed there is. Instead of applying just the white spaces and character set to our terming function, I should have used white spaces and new lines. And that trailing new line will get removed as well. So that's it for this video. With custom operators, you can really make your code more streamlined and readable. But make sure that you document your code, especially if you're working with others. So I hope you found this video useful and you'll be able to apply custom operators to one of your projects. If you enjoyed the video, please give it a thumbs up and leave me a comment and subscribe to my channel. And remember to download my free channel listing app from Gumroad so that you can easily discover more of my videos. A link is in the description.